Hello, year 11, and here we are again. We are going to carry on some work on functions this week. You might recall just before the holidays, we introduced the concept of a function. We also looked at how to substitute a number into a function to evaluate a function. And then we moved on to finding an inverse function. And the way that we did this before the holidays was to use flow diagrams and to use inverses, which, to be honest, is going to be my preferred way, but it doesn't always work. So today we're going to look at an alternative approach as to how to find an inverse for a more complex function. So the objective today is work out inverse functions by rearranging a formula. If you've managed to print out the sheet, that's absolutely great. I'm afraid if you've not managed to print out the sheet, then you will need to write all of these things down. So just a quick reminder about the notation. If you see f to the minus 1 of x, that is an inverse function, and it is the inverse function of f of x. And I've said what we're going to do today is set up and rearrange a formula to try and find an inverse function. So the first thing that I'm just going to do is I'm going to explain the process, and I'm going to start with an easier function, one that we would be able to solve using inverse function machines and flow diagrams, so you can see that the process results in the same inverse function. So we've got our function f of x equals 3x plus 5, and we're going to try and work out the inverse function. And there are 3 steps that we need to take if we are going to set this up and solve it in the format of rearranging a formula. And the first thing that we do, instead of writing f of x, we are going to replace f of x with a y. So we're going to create the formula that y equals 3x plus 5. So I've swapped out the f of x for a y. Now we are going to rearrange this formula to make x the subject. So of course I am assuming that you are good at this, and we're going to use some inverse functions. So the first inverse that I need to do is I need to subtract 5 from both sides. And if I subtract 5 from both sides, I end up with y take away 5 equals 3x. And then to make x the subject, I need to get rid of the 3, and I can do that by dividing both sides by 3. And when I divide both sides by 3, I get y take away 5 all over 3 equals x. Now, this is where I start to think that this method's a little bit gimmicky. It's remembering this last step to get your inverse function that's a little bit funny. So what you do is you swap out your x with f to the minus 1 of x. Sorry, there's a little mistake there. I will fix that. So this is now going to be my inverse function. And what I have to do on this side is swap any of my y's with an x. So my inverse function is now x take away 5 divided by 3. So it's probably worth just convincing ourselves that this has actually worked. Now, obviously, if we were doing this using our prior method of function machines, we would have said that the function machine 3x plus 5 is a timesing by 3 machine, plusing 5, and f of x popped out. And then if we wanted to do our inverse machine, we would work it backwards by taking away 5, dividing by 3. So the inverse function would be x take away 5 over 3. So what you can see there is we have got the same result using this other method. So let's look at a different example. It says, given the function f of x equals 10, take away 2x, evaluate the inverse function of f of minus 1 of 2. So obviously remember that this notation means that we're going to have to work out the inverse function and then substitute the value of 2 in there. So I'm going to use this new method. So I'm going to set up my formula, y equals 10, take away 2x, and I'm going to rearrange it to make x the subject. Well, one thing that I don't like to begin with is this negative 2x. So I'm going to start by adding 2x's to both sides of my formula to make the x positive. So I now get y plus 2x equals 10. If I'm going to try and make x the subject, the next step is to subtract y from both sides. If we subtract y from both sides, we get 2x equals 10. Take away y. And finally, to get x by itself, I'm dividing by 2. And if I divide both sides by 2, I get x equals 10 minus y, all divided by 2. So let's write that as an inverse function. So remember, I swap this for f of minus 1 of x, and I swap any y for an x. So it's 10, take away x, divided by 2. Not quite finished, because remember, we were evaluating the inverse function with 2. So all I have to do now is substitute 2 into this. So 10 take away 2 would be 8, and 8 divided by 2 would be 4. Okay? One thing that I can actually check if you're interested is I can put 4 back into my original function and see, do I get the answer of 2? Because if 2 maps to 4 using the inverse function, 4 must map to 2 using the normal function. And 10 take away 2 4s, 8, 10 take away 4 gets us back to 2. So there was a little bit of a way of checking that answer. So for my third and final example, we're going to look at a more complicated function, one where the variable appears twice. And you might remember rearranging some of these sorts of questions earlier in the year. So it says, given the function f of x is equal to 2x plus 10 divided by 5 take away x, evaluate the inverse function f of minus 1 of 10. So let's set up the initial formula that we're going to rearrange. So remember, I'm swapping the f of x for a y, and it equals 2x plus 10 divided by 5 take away x. Okay, now the first thing that I'm going to do is I'm going to get rid of this divide by 5 take away x by multiplying it onto the other side. So all I've done is taken the 5 take away x to the other side. It's going to be multiply. I am now going to expand my bracket. So 5y take away xy equals 2x plus 10. Now, do you remember from here what you need to do to make x the subject? Well, I need to get all the terms with x on one side and all the terms without x on the other side. Now, since this is a positive x here and this is a negative x here, I'm going to move all of my terms with x onto the right hand side. So I'm going to start by adding xy to both sides. So that was adding xy to both sides. Now on this side, there's still a term that doesn't have an x in it. So I'm going to get rid of that plus 10 by subtracting 10 from both sides. If I subtract 10 from both sides, I'm now left with 2x plus xy equals 5y take away 10. Now, remember, if we want to make x the subject and it appears more than once, we have to do a factorisation to fix that. How would this factorise? Well, if I took x out as a common factor, I'd need a 2 for the 2x, and I'd need a plus y for the xy. And this side is still 5y take away 10. Finally, I'm just going to do a little division. To get the x by itself, I'm going to divide by 2 plus y. So I end up with 5y take away 10 equals, 5y take away 10 divided by 2 plus y equals x. Now let's set up the inverse function. So the inverse function, remember I'm swapping that for this. And any y's I need to replace with x's. So it's 5x take away 10 over 2 plus x. And it asks us to evaluate the inverse function of f to the minus 1 of 10. So let's try doing this. If I put 10 in here, 5 tens would be 50. Take away 10 would be 40. And 2 plus 10 is 12. So it's 40 divided by 12. And 40 divided by 12, well, 12 goes into 40 3 times, with 4 left over, and 4 divided by 12 is a third. So it's 3 and 1/3. Now, once again, if we wanted to, and I'll perhaps leave this to you and use your calculator, if you substitute 3 and 1/3 into this expression here, you should get the answer 10. And that would be a nice way of checking that you've got this one right. So there are some questions for you to try, and I will have left a link in the instructions to a copy of this PowerPoint, so you do not need to pause the video here. You can just access these questions, and there will be the answers to these questions on the following slide. So do as many as you can with the time that you've got left. If it doesn't look like you're going to finish them all, may I suggest you work down columns A, B, C and D. That way you'll be progressing to some of the harder questions sooner. And I'm sure I don't need to remind you that the inverse of a square root is squaring something. Of course, if you have any problems with any of these questions, feel free to contact me in the Ask the Teacher channel. If you want more detailed answers because the slide just has the final answer, then let me know and I'll post some of those online.